Welcome to Vidaysketara YouTube channel, a dedicated place for developers, learners, and professionals to upgrade their knowledge with real-world concepts and practical explanations. Hey developers, welcome back to the channel. In today's session, we are going to unlock one of the most important principles in clean coding and professional software development, the Interface Segregation Principle. If you've ever dealt with messy interfaces, classes forced to implement unnecessary methods, confusion during maintenance, or bugs appearing because of overloaded interfaces, then this video is absolutely for you. Today, I'm going to explain the Interface Segregation Principle in the simplest way possible with real examples, real coding scenarios, and crystal clear explanations so you can confidently apply it in your projects. Watch till the end. Once you understand ISP properly, your object-oriented design skills and architecture thinking will completely transform. Let's begin. Now let's understand the official definition of the Interface Segregation Principle. The Interface Segregation Principle states that no client should be forced to depend on interfaces it does not use. In simple words, an interface should not be big and overloaded with many unrelated methods. Instead of one fat interface, we should create multiple small, focused, and meaningful interfaces. A class should only implement what it actually needs, not unnecessary methods that lead to dummy implementations, empty methods, or exceptions. By following ISP, we ensure our interfaces are clean, purpose-driven, easy to understand, easy to maintain. It prevents us from creating God interfaces that try to do everything and force subclasses to handle things they don't care about. Why is the Interface Segregation Principle important? Because in real-world software development, requirements continuously evolve and systems grow over time. If interfaces are large and tightly coupled, any change in one part of the interface can break multiple classes, even if they don't use that feature. This creates unnecessary dependencies, makes testing harder, and increases maintenance headaches. Violating ISP leads to bloated and confusing interfaces, classes implementing unnecessary methods, more bugs when interfaces change, tight coupling, and fragile designs. But when we follow ISP, our code becomes more predictable, more stable, easier to maintain, safer to extend. Developers can build only what is needed without being forced to depend on extra, irrelevant functionality. This leads to cleaner design, better architecture, and truly professional quality software. In simple words, the Interface Segregation Principle helps us build professional, reliable, and maintainable applications by ensuring that classes only depend on the features they actually need. Instead of forcing classes to implement unnecessary methods, ISP encourages us to design small, focused, and meaningful interfaces. This keeps our code clean, logical, and trustworthy in real-world projects. Where do we use the Interface Segregation Principle in real life? We apply ISP anywhere. Systems need different functionalities for different clients or modules. This includes areas like payment processing, notification systems, user management, tax and business rules, reporting modules, IoT devices, API design, and microservices. Whenever different components need different behaviors, ISP ensures that each one only implements what it truly requires, nothing extra. You'll see ISP heavily used in enterprise software, banking applications, e-commerce platforms, scalable architectures, and modern frameworks, where stability and flexibility are extremely important. Whenever we know that different modules require different capabilities, that's the perfect place to apply the Interface Segregation Principle. In short, we use ISP wherever we want clarity, flexibility, and low coupling in our software. We apply ISP by making sure interfaces are not too big or overloaded. Instead of creating one large God interface with many unrelated methods, we split it into multiple smaller role-based interfaces, so each class implements only what it needs. That means classes should not be forced to implement unused methods. No dummy methods, no empty implementations, no unnecessary dependencies. Instead of blindly designing giant interfaces, we think carefully. If one interface feels overloaded, we break it into smaller ones. If a component needs a special behavior, we design a separate, focused interface for it. If a class cannot reasonably support an interface method, that method does not belong there. To achieve this, we follow ideas like focused responsibilities, clear contracts, meaningful, purpose-driven interfaces, avoiding extra burden on clients. In many systems, we use ISP together with abstraction, composition, dependency inversion, and clean architecture, ensuring the system remains stable, predictable, and easy to maintain. We apply the Interface Segregation Principle by designing small, well-defined interfaces so that each class depends only on what it truly needs. Nothing more, nothing less. This prevents surprises, reduces bugs, and helps us build clean, scalable, and truly professional software. Let's now look at some real-world practical examples where the interface segregation principle is actually used in the software we use every day. Payment systems. Think about e-commerce platforms like Amazon, Flipkart, or any online shopping website. They support different payment experiences such as online payments, wallet payments, installment, EMI payments, refund processing. Now, instead of creating one huge payment interface with every possible method, like pay, refund, EMI process, wallet recharge, generate QR code. ISP says, don't force every payment class to implement all these methods, because not every payment method supports everything. ISP violation, wrong approach. In a bad design, we create one fat interface like iPayment with too many methods. Then classes like credit card payment, UPI payment, PayPal payment are forced to implement methods they don't need, leading to dummy method. Implementations, empty methods, throwing not supported. Exceptions, confusing, bloated, and risky code. This clearly violates the interface segregation principle because clients depend on methods they do not use. ISP done correctly, right approach. In the correct design, we break the big interface into multiple small focused interfaces, such as iPayment, iRefundable, iEMI support, iWallet feature. Now, credit card payment implements iPayment plus iRefundable UPI. Implements iPayment, wallet implements iPayment plus iWallet feature. EMI services implement iEMI support. This way, each class implements only what it needs, no useless or empty methods. System becomes cleaner and easier to maintain. Instead of a bird flying problem for LSP, here ISP fits beautifully in the same concept. ISP violation. We create one interface, iBird, fly, walk, swim. Now every bird must implement fly, walk, and swim. But sparrow cannot swim. Penguin cannot fly. Ostrich cannot fly. So developers end up writing empty methods, not supported exceptions, meaningless implementations. This violates ISP because these birds are being forced to depend on behaviors they don't need. ISP done correctly. We redesign using small, focused interfaces. iBird, iWalkable, iFlyable, iSwimmable. Now Sparrow implements iBird plus iFlyable. Penguin implements iBird plus iSwimmable. Ostrich implements iBird plus iWalkable. This gives correct behavior, No forced methods. Cleaner architecture. Zero unnecessary dependencies. Do not create giant interfaces that force classes to implement things they don't need. Instead, split them into small, meaningful role-based interfaces so every class uses only what is required. That is the true power of the interface segregation principle. Consider applications that send notifications. At first, they may support only email notifications. Later, requirements come to add SMS, then push notifications, then WhatsApp alerts, and many more in the future. Now, instead of creating one big notification interface with every possible method like send email, send SMS, send push, send WhatsApp. The interface segregation principle says, don't force every notification class to implement all these methods. A class should only depend on the features it actually needs. ISP violation. Wrong design. In a bad design, we create a single, large, God interface like iNotification, send email, send SMS, send push, send WhatsApp. Then, email notification is forced to implement SMS and WhatsApp methods. SMS notification is forced to implement push and email methods. Push notification is forced to implement WhatsApp and email methods. So developers end up writing empty methods, dummy implementations, not supported exceptions. Confusing and fragile design. This clearly violates the interface segregation principle because classes are forced to depend on methods they do not need. ISP done correctly. Right design. Now let's look at the correct ISP-compliant approach. Instead of one large interface, we create small focused interfaces, such as iEmail notification, send email message, ISMS notification, send SMS message, IPUSH notification, send PUSH message, IWHATSAPP notification, send WhatsApp message. Now, email notification implements only iEmail notification, SMS notification, implements only ISMS notification. Push notification implements only iPush notification. WhatsApp notification implements only WhatsApp notification. This gives clean and meaningful interfaces, no unnecessary methods, no runtime surprises, easy to maintain and extend. Practical behavior. Example: if SMS has limitations like shorter message length, it can handle the behavior internally, truncate, split message, etc., without being forced to implement unrelated features like email or push. No empty methods, no forced features, no broken contracts. Everything is structured, logical, and predictable. Core meaning of ISP. Here, do not create large interfaces that force classes to depend on unnecessary features. Create small, role-based interfaces so each class implements only what it truly needs. That's the true power of the interface segregation principle. It keeps systems clean, modular, stable, predictable, and professional. Consider applications that send notifications. At first, they may support only email notifications. Later, requirements come to add SMS, then push notifications, then WhatsApp alerts, and many more in the future. Now, instead of creating one big notification interface with every possible method like send email, send SMS, send push, send WhatsApp. The interface segregation principle says, don't force every notification class to implement all these methods. A class should only depend on the features it actually needs. ISP violation. Wrong design. In a bad design, we create a single, large, God interface like iNotification, send email, send SMS, send push, send WhatsApp. Then, email notification is forced to implement SMS and WhatsApp methods. SMS notification is forced to implement push and email methods. push notification is forced to implement WhatsApp and email methods. So developers end up writing empty methods, dummy implementations, not supported exceptions. Confusing and fragile design. This clearly violates the interface segregation principle because classes are forced to depend on methods they do not need. ISP done correctly. Right design. Now let's look at the correct ISP compliant approach. Instead of one large interface, we create small focused interfaces such as email notification, send email message, ISMS notification, send SMS message, IPUSH notification, send PUSH message, IWHATSAPP notification, send WhatsApp message. Now, email notification implements only iEmail notification, SMS notification, implements only ISMS notification, push notification implements only iPush notification, WhatsApp notification implements only WhatsApp notification. This gives clean and meaningful interfaces, no unnecessary methods, no runtime surprises, easy to maintain and extend. Practical behavior. Example: if SMS has limitations like shorter message length, it can handle the behavior internally, truncate, split message, etc., without being forced to implement unrelated features like email or push. No empty methods, no forced features, no broken contracts. Everything is structured, logical, and predictable. Core meaning of ISP. Here, do not create large interfaces that force classes to depend on unnecessary features. Create small, role-based interfaces so each class implements only what it truly needs. That's the true power of the interface segregation principle. It keeps systems clean, modular, stable, predictable, and professional. In banking, finance, or government systems, tax rules and business policies frequently change. There may be different types of tax-related behaviors, such as income, tax calculation, GST calculation, VAT calculation, surcharge processing, yearly policy-based rules. Now, instead of forcing every tax module to support all these behaviors through one giant interface, the interface segregation principle says, don't create one big God interface like iTax rule, calculate income tax, calculate GST, calculate VAT, apply surcharge, process yearly policy. Because not every tax module needs all of these. Each rule has a different purpose and different logic. ISP violation, wrong design. In a bad design, developers create one large interface and force every tax class to implement unnecessary methods. For example, income tax rule is forced to implement GST logic. GST tax rule is forced to handle yearly policies. VAT tax rule is forced to handle surcharges. This leads to dummy method implementations, empty methods not supported, exceptions, confusing and tightly coupled code, unnecessary complexity and maintenance headaches. This clearly violates the interface segregation principle because classes are being forced to depend on methods they do not need. ISP done correctly. Right design. In the correct professional design, instead of one fat interface, we create multiple small focused interfaces, such as iIncome tax rule, calculate income tax income, IGST tax rule, calculate GST amount, IVAT tax rule, calculate VAT amount, I surcharge rule, apply surcharge amount, I policy, tax rule, apply policy year, income. Now, income tax rule implements only iIncome tax rule. GST tax rule implements only IGST tax rule. VAT tax rule implements only IV tax rule. Surcharge rule implements only I surcharge rule. New policy tax rule implements I policy tax rule. This gives clean separation of responsibilities, no unnecessary dependencies, no empty or fake methods, easy to maintain and extend, clear, meaningful design, practical behavior. Example: if tomorrow government introduces new tax rule, 2025, we simply create a new interface or class aligned to its behavior instead of modifying every existing tax class. Each module knows only what it needs to know, nothing more. Core meaning of ISP. Here, if a system deals with multiple behaviors, do not force every class to implement all of them. Split features into small role-based interfaces, so each tax rule implements only what it actually needs. That is the real power of the interface segregation principle, especially in financial and enterprise systems, where clarity, flexibility, and maintainability are extremely important. Plugin-based applications like VS Code, browsers, IDEs, and game engines allow users to install different plugins, such as themes, extensions, and developer tools. All these plugins are built on top of a plugin contract provided by the main system. Now, according to the interface segregation principle, plugins should not be forced to implement features they do not need. If we design one giant interface like iPlugin, load, execute, debug, track usage, save settings, then every plugin must implement everything, even if it doesn't need debug or tracking. This creates unnecessary complexity and tightly coupled code. ISP violation, wrong approach. Imagine a system where theme plugins are forced to implement execution logic. Simple extensions are forced to support debugging. Lightweight plugins must implement tracking features they don't need. This leads to dummy methods, not supported, exceptions, confusing, design hard to maintain system. This clearly violates the interface segregation principle because plugins are forced to depend on methods they don't use. ISP done correctly, right approach. In a professional design, we split the plugin contract into multiple small interfaces, such as iBase plugin, load, unload, iRunnable plugin, execute, iDebuggable, debug, iTrackable, track usage. Now, theme plugins implement only load, unload. Tool plugins implement, execute. Advanced plugins may implement debug or tracking. This ensures clean separation of responsibilities, no unnecessary features, flexible extension model, stable and predictable behavior. Decor. Meaning of ISP. Here. If the system supports plugins, give each plugin only the interfaces it actually needs, instead of forcing every plugin to implement everything. That is the true power of the interface segregation principle in plugin architectures. In many applications, logging may start with a simple file logger. Later, requirements grow. We need database logging, cloud logging, monitoring tools like ELK or Splunk, and more. A bad design mistake is creating one massive logger interface like iLogger, log2 file, log2 database, log2 cloud, log2 monitoring. Now every logger is forced to implement all methods, even if it doesn't support them. ISP violation, wrong approach. This results in empty dummy methods, not supported exceptions, rigid implementation, difficult maintenance. This clearly violates ISP because every logger is forced to depend on unnecessary functionality. ISP done correctly, right approach. Instead, we design small, focused interfaces. iFile logger, stations log2 file, message. iDatabase logger, log2 database, message. iCloud logger, log2 cloud, message. iMonitoring logger, module log2 monitoring, message. Now, file logger implements iFile logger. Database logger implements IDATABASELOGGER cloud. LOGGER implements ICLOUDLOGGER monitoring. LOGGER implements IMONITORING LOGGER. This gives clean and meaningful design, zero unnecessary dependencies. Easy testing and extension. Highly maintainable logging system. Core meaning of ISP. Here, if the system expects logging, don't force one logger to handle everything. Give each logger only the responsibilities it truly needs. That is the true power of the interface segregation principle in logging systems. Now let's talk about the advantages of the interface segregation principle and why it is so powerful in real-world software development. First, it makes our code clean and maintainable. Since classes implement only the methods they actually need, we avoid unnecessary complexity, empty methods, and confusing code. The design becomes easier to understand and maintain. Second, it reduces unnecessary dependencies. ISP ensures that classes are not forced to depend on features they don't use. This keeps components lightweight, less coupled, and easier to modify without affecting unrelated parts of the system. Third, it improves flexibility and scalability. When new features are added, we can simply introduce new small interfaces without breaking existing ones. This allows systems to evolve smoothly as requirements grow. Fourth, it enhances stability and reduces bugs. Because interfaces are smaller and more focused, changes in one area don't accidentally break other components. This increases reliability and makes systems safer to enhance. Fifth, it promotes professional design thinking. ISP forces developers to clearly think about responsibilities and roles instead of dumping everything into one massive interface. This leads to cleaner architecture and better long-term code quality. In simple words, the interface segregation principle helps us build clean, modular, predictable, and enterprise-ready applications, where every component gets exactly what it needs, nothing more, nothing less. Disadvantages. Limitations of ISP. Now let's be honest, even though ISP is powerful, it also has some challenges developers should understand. First, it requires good design understanding. Beginners may find it difficult to decide how to split interfaces correctly, which may lead to over-segmentation or wrong abstractions. Second, it may increase the number of interfaces. Since we split big interfaces into many smaller ones, the number of files and contracts increases. Without proper organization, this can feel overwhelming. Third, it can be misused. If developers over-apply ISP and create extremely tiny interfaces without real need, the design may become fragmented and confusing rather than helpful. Fourth, refactoring may be required in existing systems. If a legacy project has fat interfaces, applying ISP means redesigning, restructuring, or rewriting parts of the system, which takes time and effort. Finally, it may feel unnecessary for very small projects. For small or single-purpose systems, too many segregated interfaces may feel like over-engineering. So while ISP is extremely valuable, it should be applied thoughtfully, with proper planning and architectural understanding. Interface segregation principle in microservice architecture. Now let's understand how the interface segregation principle fits into microservice architecture and why it is very important in modern cloud-based systems. In microservices, each service is designed to handle a specific responsibility. For example, payment service, notification service, reporting service, user service, and so on. According to ISP, each service should expose small, focused, purpose-driven APIs, not one giant API that forces clients to depend on unnecessary operations. Clients should only consume what they actually need. For example, a simple consumer may only need a basic send notification. API and admin tool may need analytics APIs. A monitoring tool may need health check APIs. Instead of one huge interface, we create separate endpoints or contracts for each responsibility. This prevents consumers from dealing with unnecessary data and unwanted functionality. When applied correctly, ISP in microservices provides better reliability, clear and focused service contracts, easier upgrades without breaking clients, safer evolution of APIs, cleaner and more modular architecture. However, if services expose large all-in-one APIs, they become tightly coupled, harder to change, and risk breaking multiple consumers at once, clearly violating ISP. The Interface Segregation Principle ensures that every class, module, or service depends only on what it truly needs. This makes software clean, modular, maintainable, scalable, and truly professional. Great! Here is your fully updated closing section, rewritten for the Interface Segregation Principle, ISP, while keeping the same tone, flow, and powerful YouTube narration style. However, we must also be careful. Creating too many unnecessary or poorly designed interfaces can increase complexity and confusion. If interfaces are badly split, projects may end up with fragmented responsibilities instead of clean design. So the interface segregation principle should always be applied with clear responsibility design, meaningful boundaries, and proper architectural discipline. In short, the interface segregation principle ensures that every class, module, or service depends only on the functionality it truly needs, helping us build clean, modular, flexible, and extremely maintainable applications. So that brings us to the end of this powerful session on the interface segregation principle. We learned what ISP is, why it is important, where it is used, how it works in real-world systems, practical examples, advantages, disadvantages, and how it helps us build reliable and professional software. If you truly understand this principle and start applying it in your projects, your code will become cleaner, easier to maintain, more scalable, and truly enterprise-ready. Remember, great developers don't just create interfaces. They design meaningful contracts that provide exactly what is needed. Nothing more, nothing less. If you found this video helpful, make sure to like the video, subscribe to the channel, and share it with your developer friends. Drop your thoughts, doubts, or the next topic you want in the comments. I'd love to help you learn more. Thank you so much for watching. This is Vidaysketara channel, helping you become a smarter and stronger developer. See you in the next video. Until then, keep learning and keep coding.